Alright, we're doing test corrections for the first 6 weeks test. I think you can do these corrections right on the test, unless somebody told you differently. Alright, get right into it. Number 1, which Venn diagram correctly describes the relationship between set R and set W, where R is real numbers, W is whole numbers. So they try to trick you with this one just a little bit, because last time when you saw this question, it was talking about irrational numbers and something, and this time it says real numbers, which we don't spend too much time looking at. But if we make our box, right, and then inside that box there was 4 smaller groups, and then we split it up. Okay, so this is natural numbers or counting numbers. Your positives 1, 2, 3. Then your whole numbers, which is natural plus 0. And then integers out here. That's your negatives as well. And then this one was rational. That's all your decimals and fractions and everything. Negative 0.5. And then over here was irrational. That's all your bad square roots and pi. Okay. And then if you remember, this is the part you had to remember, the name of this whole box was real numbers. Okay? And I talked about in my class, at least, every number you've ever seen your entire life has fit in this box, which means everything is a real number. Everything. So all irrational numbers are real. All natural numbers are real. All whole numbers are real. All integers, all rational. Okay, so our answer here is a real number had to be the big circle, and whole numbers had to be inside of that. So the answer for number 1 was B, because all numbers are real numbers, as far as we know, including whole numbers. Okay, number 2 is a little bit more straightforward. We just had to know what the square root of 92 was. Problem was, a lot of you, I think, just saw 92 and just assumed that was 9.2, and then you picked n, and that's awful. Don't do that. So let me get my calculator out here. Square root of 92. And that comes out to 9.59. So that's between 9 and 10. Closer to 10, but more so in the middle, because 9.5 would be this line in between, and 9.59 is a little bit to the right of that. So our best answer is point P. Okay? Just put square roots in the calculator, and it'll tell you, and then you find the number on the number line. It's like easy points. All right, number 3. Speaking of easy points, which list shows the table in order from least to greatest? So you can put a big old L to G here so we know which order we're going in. Then we make all these into decimals with 2 decimal places. So 0.7 is just 0.70. 2/3 you put in the calculator, right? 2 divided by 3, control, enter, let it do the work, and that gives you 0.66. 5/8, same way, gives you 0.62 or 0.63 if you rounded it. Percents, remember, take your decimal point and you move it 2 places over. 65% is 0.65. And then we just order them. So the smallest number, 0.62, and 0.65, and 0.66, then 0.70. So our smallest number should have been 5/8. So it's either C or D. And then 65 is next, and that leaves just answer C. That's it. Anytime you want to order stuff, make everything into decimals, compare the decimals. And number 3, no, that was number 3. Number 4, oh, we did pretty well on this one. Scientific notation, how we want to write it. I'm going to copy this number. Oops, I don't know where that came from. Copy this number down, so 00165. And we know scientific notation has to be between 1 and 10. Well, I don't even have to do work here. If it has to be between 1 and 10, it can't be 165, can't be 16.5, and it can't be 0.165. There's only one answer left. Oh my goodness, I don't know why anyone missed this one. Okay, that's 1.65. Let's do the work anyway, as long as we're here. It's always times 10, and we count how many places the decimal moved. That's 3. Anytime the number is less than 1, use a negative exponent. This should be negative 3. And this has to always be between 1 and 10. Because if you got this one wrong, it's because you picked an answer that wasn't between 1 and 10. And again, if you say, oh, but Ellis, I put this in the calculator and it gave me the same number, well, nobody cares, right? Because scientific notation has to start with a factor between 1 and 10. If you don't start with a number between 1 and 10, it's not in scientific notation. It cannot be correct. Okay? Let's see, number 5. Circle 1 was dilated to create circle 2. So this is the old. This is the new, original and new. Which rule represents the dilation to create that? So 2 things here. 1, dilation means multiply. I'm going to keep writing this down. So hopefully at some point you'll remember. Which means our rule has to involve multiplying, which means it cannot be C or D. If you pick C or D, you were not paying attention, and it makes me sad. Okay? From there, we look what happened. Our old circle was small, our new circle is bigger, so this is an enlargement. Get bigger, enlargement, which means the scale factor is greater than 1. So whatever we multiplied had to be something bigger than 1. So if I look at my 2 remaining choices, I've got 3 to 8 or 8 to 3. Only one of those is greater than 1, and that is B. If this wasn't multiple choice, you need to know where 8 over 3 came from. Remember, we say scale factor is always equal to, the new, I almost did this backwards, divided by the old. And since this is a circle, it's nice and easy. Any of these points, we look for corresponding parts, is always 8 on the new and 3 on the old. So it's always 8 over 3, which is that number. Okay? But more often than not, you don't even need these numbers. You just need to know, is it getting bigger? Then I'm going to multiply by something greater than 1. Okay? And then never pick these plus or minus. That's not for dilations. Alright, number 6. Area for rectangles in square centimeters are listed below. Which list shows the areas ordered from least to greatest? So we said make all these into decimals, and they did most of that for you. This is 3.20. This is done. This is done. 3 and 1/8 is 3.12 or 13, depending again how you round it. Again, this is least to greatest, so we needed to start with the smallest number. So the smallest one on this list is 3.08, and then 3.18. No. Ignore me. That was wrong. Sorry. Next one is 3.12. Then 3.18, then 3.20. We should have started with 3.08 and then gone to 3 and 1/8, then 3.18 and 3.2. Gives us the correct answer of F. Okay. Let's see, most people got that one right. Some people pick G. They just put the fraction first. Who knows why? Put your fractions in the calculator. Make them decimals. Number 7. Quadrato, all this is dilated with a scale factor using representation xy goes to 3x, 3y, which of the following can be a vertex of dilated quadrilateral. Alright, so I'm just going to copy my original points down. 0, -4. And you could plot this as well. That would be fine, but I don't have time for that. I'm just going to do math. 4, 7, and I, 9, 0. And my rule says x, y goes to 3x, 3y. So my scale factor is 3. That's what this number is. That's the scale factor. And since dilate, where does it say? Dilate means multiply. I'm going to keep writing that down. So I'm just going to multiply all my points by 3. Okay, so f prime, 0 times 3 is 0. Negative 4 times 3 is negative 12. 0, negative 12, that's not an answer. I'm going to keep going. G prime, same thing. I'll multiply both these by 3. So negative 3 times 3 is negative 9. 4 times 3 is 12. Negative 9, 12. Hey, look at that. Nailed it. I'm going to do these last two just in case I made a math mistake. It could happen. 4 times 3 is 12. 7 times 3 is 21. 12, 21, not up there. One more. I prime. 9 times 3, 27. 0 times 3, 0. 27, 0, that's not up there. The only one that matches is C. That's all I wanted you to do. Anytime it says dilate, just multiply everything by the scale factor. Those are your new points. You get your answer. Alright, look at this list of real numbers below. Which number in this list is the largest? Okay. So, what do we got here? 38, 43. A couple of these are 39, so let's make them all good decimals. So 38.50, negative 43.33, 39.60, and negative 39.50. Which of these is the biggest? So the greatest. And we need to remember, they're all negatives, so let's consider how negative numbers work. So if this is a number line, 1, 2, 3 on the right. So the bigger numbers, right, go to the right. So the further to the right you are, the bigger it is. When we look at negatives, what happens? As the numbers get bigger, right, 1, 2, 3, they actually get smaller because they're moving to the left. So when we're talking about the greatest negative number, we're actually looking for the smallest value, right? It's the smallest whole number equivalent. So if we say 38, right, is closer to 0 than 43. 38 is closer than 39 to 0. So the biggest number on this list, right, 38.5. Because if we made our number line, if we went all the way out, this would be 37, 38, 39, negative 40. If we kept going, this would be negative 43. And then the one furthest to the left, the one furthest to the right, sorry, would be negative 38.50. Let's see, here's 43, 39.5, and 39.6. Okay? So the smaller the value on a negative, the greater it actually is. Okay? Bigger the negative, the smaller it is. Okay, a little bit more straightforward. Which of these is represents a dilation as a reduction? So reduction means gets smaller. And if it's getting smaller, it means the scale factor is less than 1. Furthermore, if it's a dilation, you know what that means. Dilation means multiply. So again, there's no reason I should have picked C. How many people pick C so I can be upset? 1, 2, 3, 4, 5, 6 people picked C. That makes no sense. Okay. So then I know I'm multiplying, so it's 3.3 or 2. Which of those is less than 1? It's 0.3. That's should have been an easy question. Okay. Number 10. Which value of x makes the inequality true? So I want to make both these decimals. So 1/8 is 0.12, 0.13. 18%, remember we said move the decimal 2 places, gives us 0.18. So we want the decimal between 0.12 and 0.18. Which is it? So 1/5 is 0.2. That's not it. 1.6 is 1.6. That's not it. Some people pick this. I don't know why. 0.09 is too small. So that just leaves the square root of 0.02. And if I'm like, well, I don't know what the square root of 0.02 is, but I have a calculator. And the calculator does work for you. And the calculator is telling me that the square root of 0.02 is 0.141421. This goes on forever because this is an irrational number, right? It's not a good square. Like a fun bonus fact. But 0.14 is definitely between 0.12 and 0.18. So this is our correct answer. Okay, that's all. Use your calculator. Except for this one. Don't use a calculator for this one, it won't help you. This one we're going to have to write on our paper. So which proportion must be true? Must be true. So I need to go through this and see which of these is everything lined up correctly. These are all kind of different. That's a bit of a pain, but that's okay. So let's start with AE. AE. Okay. If this proportion is true, then one of these two should be another side from our left shape. And one of these two has to be the corresponding side on our other shape. So I need AE and VZ to be somewhere lined up. And it is not. It's down here, but diagonally is not lined up. That's bad. Don't do that. So this is not true. Okay, so we try again. Next one says AB. B. So again, we need this to line up with something else from this shape, and we need it to match up with WV. So one of our ratios should be WV. There it is. Okay, cool. And then we need YZ to be on this shape, and it's not. Okay, this cannot line up with the second side from the right shape because that is not how proportions work. So this is also not good. It's closer, right? Or halfway there, but it's not enough. Okay? Because this is, we made the key for this. This would be left shape over right shape. And YZ is absolutely not on the left shape. So that does not work. So we keep trying. We go to the next one. So BC. Again, we need one more side from here, and then the side that corresponds to BC, which is WX. And WX isn't here at all. This is even worse than answer A. Let's cross that one off. And now we're running out of answers. So either D is correct or I made a mistake. So I hope D is correct. So it starts off with AB again. Okay. So we know this should go with VW. We have AB over VW. All right, cool. CD, that works. That's a side on the left shape. So CD needs to correspond to XY. So I'm going to look down at my answers and I'm going to hope that XY is on the bottom. Hey, there it is. Okay, both these ratios match up. Still have this key of left shape to right shape. Everything is good. The answer is D. One of the trickier problems on the test. Really had to think about that one. Excuse me. All right, number 12. Which of the following transformations do not preserve congruence? The congruence means same shape, same size. Preserve means keeps, and not means no. When we say which of these does not preserve congruence, which one does not keep the same shape and same size when we do it? So if we look, a reflection, we just flip the shape. if I take a shape and flip it over, is it still the same shape? And the answer is yes. We can even draw it here. A little grid. Here's a triangle, right? Looks like a foot. If I flip it and put it over here, it's still the same triangle, just facing a different way. So this one does preserve congruence. That's not the answer. Translation just means to slide. So if I took my original triangle and I just moved it, right? Still the same triangle, just in a different place. So this preserves congruence as well. Rotation just means to turn. So if I turned this triangle, right, it'd be facing a different way, but it's still, again, the same triangle. And then this one, dilation, literally means change the size. So if I take this triangle and make it bigger, is it still congruent to the original? And the answer is no. Whoops, so don't cross it off. That's the answer. So the only one where congruence is not preserved is dilations. That's true forever. Okay, 13. We're almost there. All right, ABC was translated 6 to the left, 8 up. Which rule describes this translation that was applied to ABC to create triangle ABC? Okay. So when we do translations, we add and subtract. So you can stop multiplying. So the answer is not B or D. How many people picked B or D? Few people picked D. They said times -6. Oh, gross. Well, at least they had the right idea. They knew 6 to the left was X and 8 was Y. They just chose the wrong operation. Oh well. Okay. So 6 units to the left. So we say which of our coordinates, X or Y, is capable of moving left and right. So if this is left and right, and this is the X-axis. So X goes left and right. If we go to the left, it's getting smaller. Remember our number line. So part of our rule should be XY goes X -6, comma, and then we look at Y. If it says 8 up, Y goes up and down. And if you're going up, Y is increasing. That's Y plus 8. Then we match that to an answer, X -6, Y plus 8. That's answer C, and we're done. So if you remember which way the number lines go, you can find the rules for translations. Alright, 14, pentagon, all that, shown on the grid. It's dilated, was the origin of the center, using the rule XY 1/4 X 1/4 Y to create all that. Which statement is true? We don't even have to plot this. All I need to know is what's going to be true. And if I see 1/4, which means scale factor is less than 1, 1/4 is less than 1, this has to be a reduction. Okay? So if it's a reduction, it means that the new pentagon has to be smaller, right? So it's either G or H, not getting bigger. On Y, because the scale factor is less than 1, so we pick the one that says scale factor is less than 1, and that's answer G. I don't even have to plot the point. I just have to know if my scale factor is 1/4, it's a reduction, which makes the shape get smaller. If you want to plot it, 1/4, that's like here. 1/4 of 10 is 2.5. What's this? 10/8. So that's 2 and 0.5. I can't even see. It's getting old. That looks right. And then 2 or 10/2 would be 2.5 and 1. Wait. Yeah, that's looking pretty good. And then 7/4, so this would come down to 1 and a little bit like that. Yeah, Perfect. Nailed it. Same shape, 1/4 the size. Totally unnecessary though. Ain't just extra information. This one was a little bit different. I like this question. You had to think. Triangle MMP is graphed on a coordinate grid with these vertices, dilated with a scale factor of Q. Ooh, doesn't give us a number here. To create a new triangle. Which ordered pair represents the dilations of the vertex? So we don't know what the scale factor is, but we know by now dilate means multiply. So we're looking for an answer choice that involves multiplication, and that's not this one, or this one, or this one. It's only one answer left. It says point P, which is 6, -4, so they took 6 and -4, and they multiplied both of them by whatever the scale factor is, and that's what dilations are. Look for multiplication. You multiply your points by whatever the scale factor is. Doesn't even have to be a number. You still multiply by the scale factor. Let's see. 16. Coordinates are that it's reflected across the x-axis. Which rule describes it? Okay. So I don't have to plot this. I will anyway. Why not? I'm already here. This is point A. 2, 4. B. And 4, 1. What's important here is we're going across the x-axis. I'm going to highlight my x-axis. And I'm going to flip everything over. So this is 2 above. So I'm going to go 1, 2 below. That becomes A prime. This one is 1, 2, 3, 4 above. So I'm going to go 1, 2, 3, 4 below. This is totally unnecessary. But just in case you've forgotten how to reflect points, that's what we're looking at. And I can even draw the original. Why not? Perfect art skills. Okay. But the question is, what is the rule to describe this? And so I didn't even need any of these points. I just needed some point xy. Everything's positive when we say xy. So to keep this simple, let's say point B. Point B was at 2, 4. And that went to B prime, which is at 2, -4. So what changed? X is still 2, but y went from 4 to -4. So I'm looking for, I can even write it here, xy goes to, x is the same, so still just x, but 4 went from positive to negative, so I need the opposite of y. So the opposite of y is -y, and that's my rule. And that's the one I started underlining. I didn't even know that. There it is. That's how reflections work. It's the same thing here, right? If you say, but this one's already negative. Okay. So that was -3, 2. And it went to -3, -2. So x, even though it's negative, but it stays the same. That's what the rule means. Did the sign change? No. Whatever's negative stays negative. Did my sign for y change from 2 to -2? Yes. That's why I put -y. Okay. All right, and then number 17. This is the worst question on the whole test. Math teacher perspective, this is not a great question. I hope this one gets thrown out. Tell your congressperson. This figure A, the large figure, was dilated with the origin as the center to create figure B, the small figure. Okay. Which dilation represents the rule that was applied to figure A to create figure B? Okay, so we're going from figure A to figure B. And to keep this simple, instead of looking at the points, I'm going to say, what is this length here? So I'm going to count 1. Let me make my loops. 1, 2, 3, 4, 5, 6. So I'm going to say this is 6. And this one down here. Oh no, that's a half. That's okay. Okay, so I got 1, 2, and then 2 halves makes a whole, so that's 3. Again, this is not a great question. That's okay. We can do this on the bottom too. It's a little bit more straightforward. Let's see, 6 to 3. And figure B, this is our new shape. The 6 comes from our old shape. And we said scale factor equal to new over old, or 3 over 6. And 3/6 simplifies to 1/2. So we can say this new figure is half the old one. Okay. So what would we multiply by? We'd multiply by the scale factor, which is 1/2. So the answer, according to the paper, is D. Okay. If you got something different and would like to explain why you got something different, like if you got C, tell your math teacher. Make your case. Other than that, we're done. Okay. Good night.